Good morning, everyone. Thank you for joining our webinar today. This will be part 2, design and install. We'll be covering everything that you'll need to know for designing and installing a solar array. If you have any questions throughout this webinar, make sure to ask it in the questions or put your little hand up. Make sure to take notes, submit any questions during this time. Kyle and Jeremy will be presenting today. Just really, if you have any questions, please let us know. We actually have some questions right now. Some of these questions I will actually get to later on whenever we go through those. So let's go ahead and start. Today we're going to cover how to design a solar array, the software that we use called Aurora, on-site proposals, component overview, electrical overview, and then safety precautions, and then another Q&A. But like I said, feel free to ask any questions throughout it. My name is Carly. I'm in marketing and sales with the solar team. And then today we will also have Jeremy Vonderhaar, who is in inside sales, and Kyle, who is inside sales manager, presenting today as well.
Okay. Hello, everyone. So like Carly mentioned, my name is Jeremy Vonderhaar. I'm part of kind of the design team for solar here at Enertech, working on sizing out the systems and developing some layouts for those systems. So let's get it right into how to size out a solar array, or take you through the steps that we use. So step 1, typically, first thing you want to do every time is determine the annual electric usage for that location. So to do this, ideally, you want to get 12 months of concurrent utility information for that location, as well as, let's say you're working on a place that just moved into a location so they don't have 12 months, then it's a little bit trickier. So you want to do your best to find that average, and let's say you only have the summer months, then you'll want to look at what heating and cooling equipment they have so you can make a good estimate based on their winter loads as well.
Like new construction?
Correct. So new construction is tough as well, but it is doable. So new construction, you want to look at their heating and cooling equipment, try to figure out their heating and cooling loads annually for that location, as well as their hot water usage, anything like that. But if you ever have any new construction projects that come up, just feel free to get in touch with us, and we'll try to help you out with that as best we can. So after we determine the annual kilowatt hours used up by that location, we're going to go ahead and divide that by 1.4 to arrive at our AC system size. Now this 1.4 is derived from the annual sun coverage for that location, so it's going to vary state by state. So Phoenix, Arizona is going to have a lot more annual sun coverage than, let's say, Alaska. So in Phoenix, we may be looking more so at like a, let's say, for example, sake, a 1.7, whereas in Alaska, we'll be looking at like a 0.9, something like that. But typically for us here in central Illinois, 1.4 works out pretty well for the most part.
And that's our latitude. So other areas with the same latitude would apply for a big section of Illinois and a little bit further south, right?
Right. And they're called solar insolation maps. You can find online pretty easily, which will pretty well tell you based on your location what you're looking at. So once we arrive at our AC system size, we're going to want to go ahead and figure out how many modules we need to cover that size. So let's go ahead and walk through a couple examples. So right here, I've got a microinverter problem as well as a string inverter. So jumping into the microinverter one, let's say we have an annual usage of 16,000 kilowatt hours for that location. We're going to want to divide that by 1.4 and come up with 11,428. Now, because each of our microinverters is rated at 500 watts, we're going to want to divide that 11,428 by 500. And that's going to tell us how many microinverters we'll need on that location to arrive at that AC system size. So dividing, we get 22.8, rounding up 23 microinverters. And since each microinverter holds or covers 2 panels, we're going to want to multiply that by 2. So to cover that 16,000 kilowatt hour usage for that home, we're looking more so towards 46 modules on a microinverter setup. Now, looking over at a string inverter setup, let's say their annual usage is at 14,000 kilowatt hours a year. We're going to want to divide that by 1.4, and we get 10,000. So 10,000 divided by our panel wattage, let's say in this case we're going to be using 340 watt panels. We're going to come up with 29.4, rounding up 30 panels to cover that 10 kW system size. And for that, stuff like this, though, you want to be sure that we're always using PV watts to confirm the DC wattage so that we're receiving the expected output for that location. So getting into PV watts, I'm just going to run through a quick of basically how to use it correctly if you're using it. So first thing you want to do, so for the screenshot I've got up here, I already put in the location. So you're going to be inputting the location for whatever install site you're working on. And you're going to come to this screen here, system information. So for this, we're looking at our DC system size. So we arrive at that using panel wattage times panel count divided by 1,000. That's going to give us our DC system size. We're also looking at module type. So everything that Enertech works with is going to be premium. You'll want to put in for that section. System loss, typically, I think it auto inputs system loss around 14% in there. But solar's come a long way in the last few years, so typically the system loss is right around 5% now. Tilt, this is going to refer to either the roof pitch that you're working on to put up a roof mount or whatever tilt you're going to have your ground mount at. So for ground mounts, typically the tilt you want to be looking at is 30%. And then azimuth just refers to which cardinal direction you're going to be facing. So south is going to be 180 degrees, west 270, east 90 degrees, and north 0 degrees. That's basically just a quick overview of how to use PV watts effectively. And once you have all that information in from your proposed layout or installation for that site, it's going to give you the expected output for that system.
What's the domain address for PV watts?
I believe if you just Google pvwatts.com, it should take you to it. I think it's a government agency, NREL. You should be able to find it pretty easily just by Googling PV watts. It's a free program.
I will put the domain in the chat section too.
Okay, awesome. Okay. Moving on from there, let's look at location and aesthetics of your system. The location, what do we want to look at? First thing we want to look is which area of the roof receives the best sun coverage, basically, for this install. This is going to tell us where we're looking to put panels up for it. Is there a south-facing roof on that location that's suitable to put panels up that we can fit as many as we can onto? And on the note of south-facing roofs, a lot of people say that south is almost the only option for solar, which isn't true. East and west are still good to put panels on. They're just not quite as good as south. So south is best, but east and west are also viable if you've got a roof like that.
North is just terrible.
Right. Stay away from north. It has a pretty low efficiency rating on it. So next thing we want to look at is there any trees around that location that are going to be shading out the proposed ground mount or the proposed roof mount for that we need to work around. In fact, we've even had a few people who actually take out trees to be able to put array stuff on their roof. Then we also want to look at, let's say the homeowner wants to do a roof mount, but you get to the location and you see that their roof just isn't really suitable for solar. Well, can we start looking at a ground mount for that location to still provide them with cut in utility costs, and still giving them an option, basically, if they're able to go with the ground mount. So just something you want to check and see. On the aesthetics portion, does the homeowner want panels on the front of the home? There's a lot of jobs and subdivisions, for example, where homeowners won't always want them on the front of the home, even if that is their good southern-facing roof. So it's just something you might have to work around and get the homeowner's input on. And also, is there a color preference for the homeowner? So typically we work with what we call white on black panels, as well as, or white on white technically, as well as black on black panels. So black on black panels are typically smaller. They're a 60 cell panel and they have lower output, but from an aesthetic or design perspective, they look better on some homes and some people's opinion. So you really just want to make sure you have that homeowner's input on what you're working with.
Typically, the black on black will be the black frame black back sheet, and black racking. And that does come with a higher cost. However, it does look very camouflaged into a roof, and aesthetically pleasing as well. So
Right.
it just depends on where the location is and where the consumer, or how the consumer wants it to look on their home.
Absolutely. So getting into the program that we use to design out a lot of our layouts, it's called Aurora. And what Aurora does is it's a solar design software. And what we've seen or gotten the most success out of with it so far is using it as basically it's your first preliminary plan to get an idea of the installation site. It'll pull up an aerial image based on the address that you input into it, pull up the home for you, and you can start designing that roof and get just an idea to go to the homeowner with of what you think the best layout for that location will be, how many panels you can get up on it, stuff like that. And then you can also use it as a proposal tool to give homeowners the professional documentation on their proposed system. There's some pretty neat stuff that you can end up doing with it.
So now we use that program, and we can do that for you. But after you get up and running with your jobs, and you do a handful, and you've got people asking for questions or asking for proposals, at that point you may consider actually getting this for yourself too.
Okay, and looking quickly at on-site procedure, what you want to do when you actually go and visit the site, what are the important things you want to make sure you do? So when you're at an installation site, again, roof or ground mount works best for that. If it is a roof mount, we really want to look at roof suitability requirements for that location. Is that roof 10 years or younger? If it's not, typically may not be the best idea to put a solar array up on that roof if it's going to need to be replaced in the next few years, because then you're going to have to take that entire array off of it just to replace that roof. So it's one of those things you want to really be sure to look at. You also want to see on that roof if it does have sufficient sun access to be suitable for solar as well. If you're there, you also want to try to find out where your breaker location is, and also figure out the phase and service voltage you're going to be working with, because those are going to dictate what type of inverter and equipment you're using on that system. If it is a roof mount and you have a proposed layout for that roof, but you think it may be a little tight, be sure to go ahead and get up on that roof and measure out the areas that you're going to need just to make sure that system will fit. And let's say you think you fit all the panels up there that you possibly can, but the homeowner still needs more. Well, maybe you get up on that roof, start measuring out, and figure out you can add more panels up there too even. But if you need any help on the design side of things or figuring out materials needed, just give us a call at 618-664-9010 or email insidesales@enertechgeo.com as well.
So on that note, when we get up on top of a roof, the obstructions are up there. We need to know specifically the distance between each obstruction and the size of the roof. With Aurora, we've been dead on before, and we've been way off. So, but it is a tool to go prepared to a site visit for, and get really close to what you want to do on the roof, and give a visual to the consumer of what it will look like on top of their home or facility. And then I do want to take the opportunity to push the 8th training that we have, August 8th. That's where we'll be doing a live training. That's where we'll be getting more in depth with each topic. And as we only have about 20 minutes that we've planned for presentation time each session here, we'll be getting very in depth and getting very hands-on on the 8th. So please plan to attend that training as well. So on the next subject will be component overview for our design and installation segment. And moving on to the system load bearing, we want to look at basically the structural side of the roof, the panel size, the wind upload or wind load uplift, snow load, and structural integrity. So on panel size, those modules or panels come in 60 cell or 72 cell. Whenever you get the feet, which are the part of the racking that touches the roof itself, which kind of looks like an L bracket, we're looking afterwards with everything on top of the roof. You're looking typically around 2 to 4 pounds per square foot of roof. It really doesn't weigh that much. We have aluminum racking, aluminum frames on the modules, and the modules are pretty light themselves. Each one it ranges, but a 72 cell, for example, is about 40 pounds each. So then wind uplift is something you may need to be concerned about. It just depends on the direction of where the roof is and what you need to do to get some more modules on top of a roof. As an example, if you have a flat roof that you're doing a job on and you want to tilt to the southern exposure, then we'll have some concerns about what is from a north wind, for example, what is our wind uplift rating basically that's going to affect the system and structural integrity. Then snow load, it's really obviously something more for our mountain and northern climates. It really doesn't affect a whole lot. However, to the best of our knowledge, it really just affects the bottom or wherever there's not a module or a panel. So whenever if you have a large array, for example, on a tilted roof, if all the snow slides off that array and falls in between arrays for some reason, and you have a very wet snow, that's when it could become an issue. I don't think that there's any times that in any of our designs that we've run across the potential of that being a problem. But it is a concern to maybe take a look at, like I said, in those northern climates. And lastly is structural integrity of the roof. This may come up, and even HOAs may push this one, but with modern construction nowadays, the structural integrity of roofs is pretty good. However, on older homes or commercial facilities, you may want to just see if you can get a hold of any blueprints of the building just to make sure that it's got enough structural integrity. And if you really need to, you may find a good friend or somebody that's a structural engineer that can give you a good rate just to have them put a stamp on it that system could withstand the weight of that on top of the roof. Typically, it's really not going to be needed, but in subdivisions and other areas, it may come up as a rule that needs to be addressed. So moving on with those components for the roof installations. So on roof installs, we have modules being the panels themselves. Then we have an inverter or inverters. Racking. Racking is what is basically you have your rectangle squared module, and then your racking is your rails that go in between. Each module gets 2 rails, and then it gets a foot that connects to either the metal roof or the shingle roof or even tile roof. And then any flashing that is needed is generally incorporated into that foot so that we don't have any leaks and that you walk off the roof with the same, also call it flashing integrity as whenever you stepped up there in the first place. And then any sort of wiring that will be needed. Typically, we like to do the type of wiring where we'll go to a junction box on top of the roof that's flashed itself. And the product that we like is called a Solidec. And it's a junction box and a point of entry into the house or facility that is flashed, and it gets to hide up underneath your last module in a corner somewhere, typically. So it's a very clean-looking install, and you don't have to worry about it. Kind of kills 2 birds with 1 stone, I guess is what I'm trying to say there. I do want to make one note, though. On microinverters, we really like to push those on roof mounts. They seem to be a really good approach, even though sometimes they do add some more modules. They are high performers, and they are a very efficient way of doing an install. So they're basically plug and play, as simple as you get, with some zip ties and get you off the roof the fastest. That's kind of our approach, and that's the way we're pretty passionate about microinverters, so they do have a place. Now, with ground mounts, though, it's very similar components. So you still have our modules, we still have an inverter, I'll come back to that, but our racking consists of posts, a strong back, and then also the rails. So your strong back's basically your connector between your rails and then your post as well, and those come pre-assembled so that you open them up and you connect it to the post and the rails. And then lastly is wiring, which is very simple on a ground mount. So ground mounts are, for an installation, they're attractive because you can work off the tailgate of your truck and work quickly, no ladders. However, they do add cost. So a roof mount is going to generally be the least expensive, whereas a ground mount is going to have more material, more metals to increase that cost as well. On inverters, though, for ground mounts, we like to push the string inverter approach there because, again, wiring is very easy on the ground, and you can bring everything back to a centralized string inverter that will hang on the post, and then from that inverter, the wiring will go into the building, most likely, I guess, but we'll be going on a fast track to the meter at that point with a disconnect. So I'll get into that in just a moment.
And just real quick on the inverters of kind of the different places for microinverters and string inverters, or why we use string inverters on ground mounts. So the way microinverters work basically, where if one panel gets shaded on that array, that's not going to bring down the entire array because you have multiple other panels on multiple other inverters that are still producing energy. Whereas with the string inverter, if one panel goes down, that can stop production for that array if one panel gets shaded out, really. But on the ground mount, you typically won't have that because you have those nice out in the open spaces for your installation location, so it's not as much of an issue there.
Mm-hmm. So next would be the steps to follow to do an installation. Number one, and this is probably the most intimidating for me, is find the rafters. On a roof mount anyways. And I've heard a couple ideas that if you miss a rafter, there's the potential that you could, you want to go check before, after you get your foot mounted, you want to go back in and take a look to see, make sure that you hit them. And if you for some reason missed, or if you wanted to do it preemptively, you could actually take a couple more 2x4s and sandwich your rafter so that you have more meat essentially to mount to at that point. But it's something after you install your foot or before, it's something you do want to go back in before you start putting on your bracketry and your rails to make sure that your feet are set. Next is, I kind of took a jump forward there, but actually before you actually put your feet down, you want to use a chalk grid. And what that is after you determine where your rafters are, you want to make sure that you run a chalk line down each rafter so you know specifically where they are. And then you want to take another chalk grid line across those so that you can place specifically where your feet need to go, and you'll basically get some crosshairs at that point of where your foot needs to land. One thing that we learned that's most important out of both ground mounts and roof mounts, make it square. Everything has to be square because every step you take has to be perfectly square because your last point of the install is laying down modules. Your modules are square. So if you have an issue with your racking not being square, you'll run off your racking or it won't have the best looking craftsmanship that you could have. So make sure that you have all of your feet and racking square and take your time with that. Then level the rows with a string. This would be where you're adjusting the height of your racking. So you want to take, after you get your feet on, your brackets set, your L brackets rather, and your rails set, then come back and adjust the height of those. With an older roof, you'll see that you'll have some dips and some valleys and some high points. So you do that way that you can adjust the height, and whenever you look up at the array, it's perfectly flat and doesn't have any, I guess I'll call it ridges in between modules. And then on the wiring section of that, we'll be wiring to each array from that junction box that we talked about, and that can be done in multiple fashions, but referencing a shingle roof, we really do suggest that Solidec junction box that's flashed and a point of entry into the house, and get you from the inverter or from the array into the I guess we would use it microinverters. So we'd go from our trunk line to the junction box, and then that would get us in pursuit to the disconnect at that point. So which would be from the inverter. Then on ground mounts, we install the posts. That can be done with a post driver, or you can actually do it in concrete, and you could just auger out the hole, come back, fill it with concrete. I've heard of some people even adding in some rebar as well. And then you start to add your racking to your posts, and we actually have a live working array here at Enertech that we can take a look at on the 8th to show you in steps. And then we'll also be having one locally as well that we can take a look at that will be in process of installation. Again, on ground mounts, we got to make sure they're square. From post to post, and making sure that our racking is flush, level, and square before we ever start putting on modules. Then our wiring from the array, we're coming into that string inverter, so we'll actually be taking a daisy chain approach with our modules and bringing those back to our inverter, which will most likely hang on a post on the array itself. And then from there, we'll go from that string inverter, which has a DC disconnect in it. We'll go to the, we'll conduit into to a post or wherever that entry point of that, where that meter is rather, on a building, and that's where our disconnect will go from there. So the electrical component overview. So this is a long list, but it's definitely something to consider. That's going to be items that will be needed on the end job. So you're always going to need a inverter, obviously, with every job. You're going to need a junction box at some point so that we can take our modules and bring those into one point of entry per array. Then we're going to evaluate the breaker box, which will also include the bus bar. We may need a sub panel depending on how we want to design it, and or how the arrays come into play. If you have one array, you may not need a sub panel, but if you have more than one, you may consider a sub panel as well. So then wiring to the disconnect. That disconnect needs to be located normally within about 10 feet of the meter. If you work with your utility, which is most important, get a good relationship with the utility of where you'll be working. Talk to them first. They may have some shortcuts for you that you can maybe build a map, and you'll need some labeling as well to show that where that disconnect will go in relation to the meter. So we have wiring from the junction box to the disconnect, and then we have wiring from the disconnect to your bus bar, which will have your breaker on it. And those are basically the components of the system that are needed. And then code, NEC requirements on overloading the system. That's some detail that we will get into on the 8th. And then situation examples we'll go over on the 8th as well. License requirements, just a basic electrical requirement is usually needed, but it really depends on your local state and city requirements. In some cases, you may need a specific license to work within an area. For example, a larger city may need their own license. Labeling is a very big part of every job, and it's part of the safety requirements that are needed for utilities and for first responders for them to know how to turn down the system. As well as labeling is rapid shutdown, which is part of that NEC requirements, and rapid shutdown is basically the being able to turn off the DC system side of it to where it's not producing any power, and how is that being done, and it can be done in a couple of different ways. And then design, a one-line diagram basically showing a map of how your wiring, your system goes, so that that can be presented to the utility will be done. Wire gauge selection, and then breaker sizes as well. So safety precautions, these are pretty quick. As you can imagine, you need to be prepared with proper eye protection and hard hats. No matter if you're working on the ground or up on the roof, a hard hat and eye protection are always good things to take care of yourself. On ground mounts, proper post anchoring, make sure that everything is taken care of on that. So if you're driving the posts in, make sure that you have enough depth. And then if you're putting them in concrete, make sure that you have enough structural integrity for those posts to handle that wind load. Roof mounts, make sure that depending on roof pitch, that you use enough safety items. If you have a higher pitch roof, you may consider even a man lift to help you be supported on the roof. And then with also your roof mounting gear as well, your safety ropes. And then how are you going to get the modules on the roof? No matter if it's a low pitch, a high pitch, just running them up and down a ladder isn't the best, but it can be done. However, you may consider using a telehandler or a man lift to bring those modules up on top of the roof, and it makes you very efficient. All right, so moving on, give it back to Carly for questions and answers.
Yeah, so we have one question. What is the expected cost to the homeowner for a net zero home?
That's a loaded question. Jeremy, you want that one?
No, that's a long factored equation. Of course, it's always going to be built on the insulation value on our load calculation for what the home's going to be. That's step one. So always back to the insulation. And then we'd size our geothermal system or our heating and cooling system off of that, which, of course, we suggest a geothermal system. And then from that point, we'll size the solar array on their users of the facility. So can't really answer that, but it really does. Adding a solar array on new construction can be done in multiple ways, though. I mean, you can, if you do a roof mount with micro inverters, you can always add more later. So you could always just take care of the heating and cooling section and then add the solar modules and microinverters down the road to get them to net zero. So it's a hard equation to answer as far as costs go, but and when I say that, it's just that every job is different, but as long as we take the necessary first steps, it can be achieved much easier.
Is there any more questions? We'll stay on here for a couple more minutes to see if anyone has any more. But is there anything else you guys wanted to add?
Not really, but today's section, it's a mouthful. I mean, there's a lot to cover on the design and install side of it. However, it does sound intimidating, except that it's really not once you actually get your hands on it and start doing an install. And we feel like we've gotten the hang of it pretty well now. And on your first install or your second install, we'd love to come help you with it, even bring all the materials to you, whatever it takes. But we'd like to help you guys get going, make sure that you feel comfortable with it. But I can assure you the first time you lay your hands on it and do your first install, you'll just kind of say, well, that's it. And it's really a pretty simple process once we get into the install side of it. The design side is just a couple equations really for the most part, and we can help out a lot with that as well.
Okay, if you guys have any more questions or want any more information, feel free to contact InsideSales@enertechgeo.com. But other than that,
join us on the 1st for our next session. And we'll have Cameron from SREC Trade will be helping us on the administrative section of our next webinar. And then, of course, join us on the 8th for our training that starts at 8 o'clock in Greenville, and we'll be doing an all-day session as well for that. That session will be free, and we'll obviously include lunch as well in that. And if anybody's flying in, please let us know, and we may be able to coordinate transportation pretty easily to get from the airport to Greenville.
Yep, and we'll send a follow-up email with this, with all the information in it. I promise this time it won't get messed up like the last time. So.
All right. Well, thank you all. And if you have any designs that we can start working on now, please send those to us. Send them to me. Here's my email address. Or give us a call. You can send them to Inside Sales as well. And we'd love to work on your first ones. That way, when you come to the training or the next webinar, it's more real life. And I'd recommend either doing your shop or your personal house as well to get started. Thank you very much.